Okay, so today we are going to look at section 4.5, which is solving polynomial equations. So this first example says it wants us to solve a polynomial equation by factoring, and this is a review. We have these skills. So when we look at this equation, the first thing I see is that we can pull out a GCF that is 5x. So I'm going to factor out the GCF of 5x, and what I'm left with is x squared minus 8x plus 16. And then I still have equal to 0. Now, in the parentheses, this is a trinomial, x squared minus 8x plus 16, with a value of 1, the number in front of the x squared. So that makes this a very easy factor one. So what multiplies to 16 and adds to negative 8 is going to be negative 4 and negative 4. So it's 5x and then x minus 4 times x minus 4, and then it's equal 0. So what that means are my solutions are x equals 0, because 5x equal to 0, divide by 5, you get 0, and x equals 4, because when you set x minus 4 equal to 0, you get 4, and then the other parentheses, x minus 4 also gets 4. So this one has two solutions, which means it has two x-intercepts. Okay, on example 1b, you need to solve, and so before you can do that, everything needs to come to one side. So what I'm going to do is I'm going to go ahead and I'm going to subtract the 12x squared to bring it to the left and add the 36x. Now once again, I see right off that there's a GCF, this 2x. So if I factor out the 2x, I get x cubed minus 3x squared minus 6x plus 18. Okay, so I want to now factor what's left in that parentheses. So personally, I'm going to step out to the side and use the area model, the box method sometimes we call it. So if I go ahead and put a term in each one, so I have, x cubed minus 3x squared minus 6x plus 18. Now factor the GCF out of each row and each column, like we've been doing. So I get x squared minus 6, and I get x minus 3. So my factors are 2x, x squared minus 6, and x minus 3. Now to find those solutions, you set each one equal to 0. So when I set 2x equal to 0, I get a solution of x equals 0. When I set x squared minus 6 equal to 0, I add the 6, and then I square root. And when you square root the 6, you get a positive square root of 6, and you get the negative square root of 6. So there's two solutions that come from that one factor, x squared minus 6. And then set the factor x minus 3 equal to 0, and you get x equals 3. So my solutions are 0, positive square root 6, negative square root 6, and 3. Okay, example 2 is finding the zeros of a polynomial function. So it says to find the zeros of this function. So the first thing we're going to do if we're looking for the zeros is we're going to set it equal to 0. All right, so now to continue finding the zeros, I need to factor. First thing I notice is it has a GCF of negative 2. So I'm going to factor out the negative 2, and I'm left with x to the 4th. Sorry, that will turn into a minus 8x squared. And then that will be a plus 16. So now I can factor inside the parentheses. This is a trinomial, so if I ask myself what multiplies to 16 and adds to negative 8, that's going to be negative 4 and negative 4. So that'll factor to x squared minus 4 and x squared minus 4. Okay, each of those parentheses then are difference of squares, so they factor to x plus 2, x minus 2 on each one. Okay, let's go ahead and rewrite this. So if you see, there are two factors that are x plus 2 and x plus 2. So that can be rewritten as x plus 2 squared. There's also two factors that are x minus 2 and x minus 2. So that can be written as x minus 2 squared. All right, so that's completely factored. Now, we're going to learn something. This is getting a little ahead of ourselves, but we're going to learn something called a multiplicity. And it's when you have a factor that occurs more than once. So like how you have x plus 2 quantity squared. That has a multiplicity of 2. So both of these actually do. So if they are repeated an even number of times, that means the multiplicity is even. when it's repeated an even number of times or has an even multiplicity, meaning it has an even power, then it means it touches the 0 but does not go through the 0. So multiplicity is even, so it touches at that 0. If the multiplicity is odd, then it actually goes through that 0. So we'll see what that means in just a second. So taking from what we've learned in the beginning of chapter 4, we learned that if the leading coefficient is negative and the power is even, that it has a general shape like this. We learned about in behavior. So it has that general shape. Now, we know that it's going to go through at -2 because that is one of the zeros. If you set x plus 2 equal to 0, you get -2. And then if you set x minus 2 equal to 0, you get +2. So it's going to go through the x-axis at -2 and +2. We know the general shape that is going to open down. It's in behavior. And then also, just by looking, I know the y-intercept is at -32. So I don't have room to fit that on the graph going by 1, so I'm going to go by 4s. So this is going to be -4 and 2, 3, 4, 5, 6, 7, 8. So 8 boxes down would be -32 if I'm going by 4s on the y-axis. So remember, we said that if the multiplicity is even, it touches the 0, it doesn't go through the 0. So what that means, this is just our general shape. Remember, we're just sketching. It touches at -2 and comes back down. And then it touches at 2 and then comes back down. So that's what we mean by it touches. If it was an odd power, like to the 3rd or to the 1 power, it's going to actually go through at the x-intercept. All right, so let's look at the monitoring progress. So the monitoring progress says, solve this equation by factoring. Okay, we've done several of those. Let's take a quick review. So we're going to first subtract the 14x cubed so that it comes back to the left side. And I went ahead and just wrote it in standard form as I was doing this step. So my GCF is 2x. So that leaves me with x to the 4th minus 7x squared plus 12. Okay, so then you want to factor that. So what multiplies to 12 and adds to -7? So that's going to be a -3 and a -4. So I have x squared minus 3 and x squared minus 4. All right, so I'm running out of room, so I'm going to move up here. So the x squared minus 3, that does not factor further because it is not a difference of squares. It could become a difference of squares, but the square root of 3 isn't going to help us much quite yet. So then this becomes x squared minus 4 becomes x plus 2, x minus 2. Okay, so now to solve. From what I would do here, if I set the 2x equal to 0, I'm going to get x equals 0. Let's come back to the x squared minus 3 in just a second. If I set the x plus 2 equal to 0, I get x equals -2, and the x minus 2 equal to 0, I get x equals 2. So the x squared minus 3, you can kind of do this two ways. You can either factor it to be x plus the square root of 3, x minus the square root of 3. That's using difference of squares. Or what most people do is they just set it equal to 0 and solve. So we add the 3, and then when we square root, remember that a square root has both a positive and a negative. So that's how we get x equals the square root of 3 and the negative square root of 3. So these are our 5 solutions. Okay, and then this one says find the zeros of the function. So the first thing we're going to do when it says find the zeros is we're going to set the function equal to 0. Now I'm going to use factoring to see if I can solve for the zeros. So the first thing is it has a GCF of x. And then I say what multiplies to -6 and adds to 1. So that's going to be a 3 and a -2. So our factors are x plus 3 and x minus 2, along with the original x that we factored out as a GCF. Okay, so that gives me the solutions of 0, -3, and 2. Now, there are no multiplicities, okay? None of them are repeated zeros, like repeated twice or 3 times. So if they are not multiplicities, then that means the graph is going to go through them. When it touches and bounces back the other way, remember, is when it has an even number, like repeated zeros, when it repeats twice or 4 times or 6 times. But if it doesn't repeat or it has an odd number of repetitions, then it goes through. We're going to work on that for several days. So this means it's going to go through at all three of these places. So let's go ahead and put points at -3, 0, and 2. Now, because it is an odd power and the leading coefficient is positive, that tells me the general shape is this. We learned that earlier in the first half of chapter 4. So what that means is, since I'm just sketching, I don't need to find specific points, but I know that my general shape is going to be like this.